Boxplots are a way of showing how a distribution is skewed, similar to cumulative frequency graphs. Essentially, they tell us whether most of the values are closer to the upper end of the distribution or the lower end. So here's a couple of examples. So this one here, this box plot, this is basically neutral. This is a distribution with no skew whatsoever, really. The median is right in the middle, where the mean is right in the middle, where the median is. It's really important that we can read a box plot. So sometimes these are called box or whisker graphs. The smallest value is what we call the end of the whisker on the left side. The left end of the box is the lower quartile of the distribution. The line inside the box is the median, and the right end of the box is the upper quartile. And then logically, the largest value is the end of the right whisker. Here's another box plot with a different skew. So this time the median is way towards the upper end. So what this tells us is that most of the values, in fact 50% of the values, are at the upper end of the distribution. And we call this, out of interest, a negative skew. And on the other end you have this kind of distribution. This is a positive skew, where the median is more towards the lower end of the distribution. So half of the values approximately are at the lower end of the distribution. This is another box plot here. So this time you can see the largest value is really quite anomalous because the median is at the lower end, so most of the data is at the lower end of the distribution. This has got a positive skew, but this largest value is way off to the right, so that tells us that it's probably an outlier or an anomaly. This is sort of the other end. We could see here, this has got a negative skew. The median is quite high. The median is towards the right of the box, which tells us that most of the values are up here, most of the values are at the upper end of the distribution, but we have this smallest value which is way down at the bottom, so that tells us that the smallest value is probably an anomaly. This is how we would draw and analyze a box plot. So I'm going to identify the important statistics in the question. We have median age of 35, the youngest worker is 20, oldest is 50, the lower quartile is 24, and the upper quartile is 45. So that's all the information I need to draw my box plot. Our lowest value is 20, lower quartile of 24, median of 35, upper quartile 45, highest value 50. So I just need to now draw the box and the whiskers. So there's my box, and I'm drawing the whiskers in there. I can now do some calculations. The interquartile range, as you remember from cumulative frequency, is the upper quartile take away the lower quartile. So here, the interquartile range, which we call the IQR, is going to be 45 take away 24. That's, if you notice, that's essentially the width of the box. So 45 take away 24, giving us 21. So the interquartile range is 21. There are 120 people in the office. Estimate how many people in the office are older than 35. So this is important. We know that the median is 35. So the median is right in the middle of the distribution. So if the median is 35, then half of the people in the office are going to be older than 35. So if there are 120 people in the office, half of 120, half of the people in the office are older than the median. So that means we can say that there are 60 people in the office older than 35. I want to estimate how many people in the office are younger than 24. This again is important. 24 is the lower quartile or lower quarter value of the data. So what that means is that 25% of people in the distribution are younger than the lower quartile and 75% are older. So 25% of 120 is going to be 120 divided by 4, which is 30. So that is how many people are younger than 24. Older than 45, well, 45 is the upper quartile. So 25% of the data is going to be above the upper quartile, which again is 30. 25% of 120 is 30. Finally, I want to work out how many people are between the ages of 24 and 45. Well, we know that 30 people are under the age of 24, 30 are older than 45, and there were 120 people in the office. 30 plus 30 is 60, 120 take away 60 is 60, so we can say that there were 60 people between the ages of 24 and 25. This is represented by the width of the box, and we should notice then that 60 is half of 120, so we can say that half of the distribution lies within the box. Here's a question for you to try. Please pause the video now and have a go at it, and when you're ready to go through the answer, press play. Here is the answer. So first let's draw the box plot. That should be the box plot. The upper quartile of the ages is going to be 65. So that's how we actually draw the upper quartile on the box plot. And I've done that because I know the interquartile range and the lower quartile. So I just need to do the lower quartile plus the interquartile range. I want to estimate how many people in the department are younger than 30, so basically less than the lower quartile. 25% of values are below the lower quartile, so this is 15 people who are under 30. 25% are above the upper quartile, so 15 above 65. And then between the ages of 30 and 65 is going to be 30, essentially 50% of people. Very often we need to compare distributions using box plots. So this is a GCSE question, and the first part of the question just expects you to take some statistics from the two box plots. Firstly, we want the range. So if I look at Trefwen, so that's the rainfall in Trefwen, the largest value is 55 and the smallest value is 5. So the range is 55 take away 5, which is 50. For Naurby, it's going to be 50 and that is just 1. 50 take away 1 is 49. The median is the line in the box, so that's 30 for Trefwen, and for Naurby that's going to be 28. The interquartile range is your upper quartile take away lower quartile. So for Trefwen that's going to be 45 take away 20, which is 25. And for Naurby that's going to be 45 take away 15, which is going to be 30. So those are our values. We're now going to be expected to use these values. So if we look at B, Iona wants, decides to go to Naurby because she wants good weather with hardly any rain. So give a reason to support her decision. Well, if I look at the median for Naurby, it has a lower median. Now, the median is, as we've seen, a kind of average. So we can say that on average, Naurby has less rainfall because it has a lower median. So to say that in full, I would have to say Naurby has median value, median rainfall. So Naurby has lower rainfall on average. For C, which of the two towns has a more consistent pattern of rainfall? Give a reason for your answer, including values from both Trefwen and Naurby. Well, I would just say which of them has the lower interquartile range. And we can say that that's going to be Trefwen. So even though Trefwen has a higher range, the interquartile range gives us a better picture of the range because it's not as affected by outliers or extreme values. So I would say the one with the lower interquartile range, the lower measure of spread, because remember that's what interquartile range is going to be the one with the more consistent pattern. And I would say Trefwen, since its interquartile range, which is 25 millimeters, is lower than Naurby's, which means that the data are less spread out for Trefwen. Here are some questions for you to try. Please pause the video now and have a go, and when you're ready for the answers, press play. Here are the answers.